Classifying systems. Systems that have finite solutions are called independents. So those are your finite solutions. We write the solutions to these systems as ordered pairs, so very similar to what you saw in the first examples. Systems that have no solution are called inconsistent solutions. They're normally written as an empty set with this symbol. Systems that have an infinite number of solutions are called dependent systems. So infinite number of solutions. The reason why is that the value of one coordinate depends on the value of the other. So one coordinate depends on the other. We write the answers to these types of solutions as ordered pairs, very similar to x comma y, or the notation f of y comma y, meaning y comma y. This is also known as a parametric form. We're going to solve the first system. 9x plus 6y equals negative 18, and negative 6x minus 4y equals negative 12. So when I look at these two, I could either do substitution, elimination, or I could graph the two. However, I notice here that these three for my first equation, so I'll write number 1 and number 2. For my first equation, the system can be divided by 3 across the board. So I'll go ahead and divide each term by 3 and see what I get. So I have 3x plus 2y equals negative 6. Well, if I look at the second equation, I can kind of reduce this and simplify it by dividing by 2 and see what that comes out to be. So I get negative 3x minus 2y equals negative 6. So if I go ahead and look at these two equations now, it makes it easier for me to do elimination. So I can take the two equations. Equation 1 says 3x plus 2y equals negative 6, and negative 3x minus 2y equals negative 6. If I go ahead and add the two equations together, these 3x's cancel, but also these two y's cancel, and I get 0 on the left side, and I have 0 equals negative 12. Well, 0 will never equal negative 12, so therefore this is an empty set, and our solution is 0, making it inconsistent. And some of you all may ask, how did I know to divide by these values? Well, if you look back to previous examples that we did today, if you realize that you can factor out something, meaning you can divide by a whole number through the entire equation, try to do that first, and then see if you from there can begin to simplify and do the substitution or elimination method faster. But with the equation 1 and 2, I looked at it and noticed that there's a GCF in all three of those terms for both equations, which happen to work in my favor to cancel out things. Let's solve the system here. Well, if I look at this system, I could divide each value by by 2, and I'll get, well, no, I'm sorry, I can't divide everything by 2 because there's a value of 3 here. Only 2 and 6 can get divided. So I can go ahead and just rewrite that one. 3x plus 2y equals 6. If I look at the second equation, I can divide the second equation by 2. If I divide that by 2, I get negative 3x minus 2y equals negative 6. Well, I can go ahead and look at these equations and notice that they're all opposite. So when I add them, my equation is going to become 0 equals 0, which means that there are infinitely many solutions, which makes this dependent. Okay, So a riverboat travels downstream 16 kilometers in 2 hours. It returns the same distance in 3 hours. Find the rate of the boat in still water and the rate of the current. So this example is very similar to the worksheet that we did in class. So I'm going to highlight the rate of the boat, and I'm going to make the rate of the boat B. Then I'm going to highlight in green the rate of the current. I'm going to label that as C. So I also understand that I'm going to use the setup of distance equals rate times time. So remember we talked about kind of earlier about moving up and down the current. So for each one of these, we kind of broke this down. We wrote as distance equals rate times time. So let's say we go downstream for the first part and we go upstream for the second part. So remember, if we go downstream, that means we're flowing with the current. So we tell us that our distance for this entire thing is 16 kilometers. And then we know that our time is in 2 hours when we go downstream, and we know that it is 3 hours in return for that same distance. So it's more information there. So the distance for both of these is going to be 16 kilometers. Let's talk about the rate for going downstream. If we're going downstream, think about you're going with the current. So that means you're going to take the boat plus the current when you go with your rate, because you're flowing with the current. But we know if we're going downstream, it's going to take us 2 hours. That takes care of our first setup of the equation, which means the second one, if we're going upstream, our distance is still 16. However, the rate is going to be the boat minus the current because we're going against the current. So we're going to take a little bit longer in our rate. Like our rate is going to not be as fast as if we're going with the current. And our time for going in return for the upstream is going to be 3 hours. So I'm going to go ahead and write the equation 1 for the downstream. 16 equals 2 times B plus C. Equation 2 for the upstream is 16 equals 3 times B minus C. So from here I can do substitution by solving for B for one of these equations. So I can go ahead and set this up, and I'll look at equation 1 and distribute the 2 here. And if I distribute the 2, I get 16 equals 2b plus 2c. If I go ahead and solve for one of my values, I'll go ahead and solve for b, so I'll subtract 2c on both sides. That'll give me 16 minus 2c equals 2b. Divide each term by 2, and that gives me 8 minus c equals b. So I'll use b to substitute into my second equation. I'll do that in green with the substitution. So for equation 2, I have 16 equals 3 times, my b value now is 8 minus c minus c. And I have the value, I can go ahead and simplify and solve for c. So I have 16 equals 3 times 8 minus 2c. Now I can distribute the 3. That's 16 equals 24 minus 6c. Go ahead and do the math behind all of that. Minus 24, negative 8 equals negative 6c. Divide by negative 6. We simplify that. C is going to equal a positive 4 over 3. So that is what the current should equal. So the current, write this down here. The current is 4 and 3 kilometers per hour. Now we have to find out exactly what was the boat speed. So in order to find out what the boat speed is, we can figure out that we have the same equation. We can use either 1 or 2 to find out what the boat is by substituting in for C. So I'm going to go ahead and substitute in for C, and I'll do that in red. And I'll take the value that I found for B when I solved it for number 2. I'll do 8 minus my C value, which was 4 over 3, equals B. Multiply this by 3, top and bottom. So I get 24 over 3 minus 4 over 3 equals B. And so I get 20 over 3 kilometers per hour for my boat speed. So the current was 4/3 in kilometers per hour, and the boat speed, right, boat out here, our boat speed was 20 over 3 kilometers per hour for that speed. Okay, so your homework, a little different from last time. It's going to be all of the values that are bolded. So anything that's bolded, which is 13, 17, 24, 37, 40, 63, and 71 are your homeworks. If you have any questions, please let me know.